So for number 32, we have a roller coaster that has a mass of 500 kilograms. If the vehicle has a speed of 20 meters per second at point A, what's the force of the track on the vehicle at this point? So I'm going to make gravity 10 for this one, but again, we're looking at centripetal acceleration. The centripetal acceleration of the vehicle at point A is going to be 40 meters per second. Again, we're looking at this point right here on the diagram. Based on that, we can figure out the centripetal force, which we know is equal to the mass times the centripetal acceleration. In this case, just plugging in the numbers, we know this has to be the net inward force. So in this case, it's going to have to be acting towards the center of the circle, which at the point A is going to be upward. If you look at the force of gravity, that's going to be 5,000 newtons. So then what does the normal force, the only other force acting on the track or on the car, have to be? The answer is it's got to be 20,000 newtons larger. And so the answer to A, what's the force of the track on the car, or the normal force, has to be 25,000 newtons. For part B, what's the maximum speed the vehicle can have at point B for gravity hold on the track? So in this case, what we have for part B, we've got the force of gravity, and the normal force is going to be equal to 0. So in this case, the net force is just due to the force of gravity. What's another name for that net force? Well, the centripetal force for things moving in circular paths. And we know that's equal to the mass times centripetal acceleration. In this case, our mass is 500, centripetal force is 5,000, so the centripetal acceleration is 10 meters per second squared. How do we convert that to a velocity? Well, we know that centripetal acceleration is equal to v squared over r. Plugging in our numbers, our radius at this point is 15 meters, centripetal acceleration is 10, and so you can very quickly figure out the final velocity then must be 12.2 meters per second. Please realize you get a slightly different answer if you use 9.81 for the acceleration of gravity. Good luck, everybody.